Okay, let's look at lesson 3-9 on page 82 of your math book. Scientific notation. How can you write very large numbers using scientific notation? All right, here's your vocabulary word. Make sure you write this definition down. A number written in scientific notation is expressed as a number, hold on a second. Let me zoom back in there. A number written in scientific notation is expressed as a number greater than or equal to 1, but less than 10, multiplied by a power of 10. So you're going to have a number that is at least 1, or between 1 and 10, I guess you could say, that we're going to multiply by a power of 10. So instead of writing a number like 27 million, we're going to write it in a different way to mean exactly the same amount. So how can you write the temperature of the sun's core in scientific notation, which is what we're looking at here? Okay, so let's look at 27 million here. So step 1 says find the first factor here. For large numbers, move the decimal point to the left to make a number that is greater than or equal to 1, but less than 10. So here is our decimal place because 27 million was a whole number. And they move it all the way over to be right here between the 2 and the 7 here. All right, so why do we move it here between this 2 and the 7? Because 2.7 is between 1 and 10. So this is a number we can use as the factor to multiply by some power of 10, which will mean the same as 27 million. So you move the decimal, making it 2.7, and we have to know how many times you moved the decimal. So if you look, there's 1, 2, 3, 4, 5, 6, 7 jumps there that the decimal moved to the left. Okay, so in step 1 we found the first factor, 2.7, and the next step was to count the number of places that the decimal point moves, and you need to know the number of places and the direction. All right, so we know that the decimal point moves 7 places to the left, because the number of places the decimal point moves gives the exponent. All right, so the number of places tells you the exponent. Moves to the left indicate a positive exponent. So the power of 10 factor for this scientific notation number is 10 to the 7th. So look at this. So at first we were looking at the number 27 million. Now you know that another way to write that, which is equal to 27 million, is to write 2.7 times a power of 10, because we moved the decimal place 7 times here, right? Remember, it was over here, and then it moved 3, 6, and one more jump there, 7 places. That's why it's 2.7 times 10 to the 7th power, because we moved it 10 times, and because we moved it to the left, it's positive. And think about it, that should make sense. If I am multiplying 2.7 by a positive power of 10, and I wanted to change it back, then I know, and I want to write it in standard form, then I know I'm going to move my decimal place back to the right to make a positive, bigger number. So this is just another way to write 27 million in scientific notation. Okay, so let's look at another example on page 82. How can you write very small numbers using scientific notation? So you don't have to write really big numbers like 27 million. You can also write a really small number like they show you right here in scientific notation. So again, the first step is finding the first factor, and that has to be that number between 1 and 10. So you see that they move the decimal this time to the right, And they put it right after that first number 5, because that makes it right here 5.06, which is between 1 and 10. So we know that our first factor is going to be 5.06. All right, let's look at the next step. Okay, so now we're looking at step 2, and we need to find the power of 10 factor. Count the number of places the decimal point moves. All right, so we know we always have to count the number of places. And notice that it moved to the right, which means we're going to have a negative exponent, which maybe you haven't seen before. And since the decimal point moved 5 places to the right, it moved from here all the way over to here, right? 5 places. You are now going to multiply 5.06 times 10 to the negative 5th power, because it is negative, because if you worked this out, it would, of course, equal this number over here. And when you multiply a number by the negative power of 10, that means you'll move the decimal back to the left 5 places, which would make it this very small number. Okay, let's look at the guided practice here together. Number 1, we have 352,090,000, and we're going to write that as in scientific notation over here. And they actually go ahead and give you the first factor instead of it being this big number here. They've moved the decimal place and they put it right here between the 3 and the 5. Notice that they write down all the numbers to the right of the decimal until the rest are just zeros. So they write all the way to the 9. They have to write that 9 in there because it's actually, has value. So they have to keep the 0. So they write 3.5209. Now they want you to tell what power of 10 is. So pause me and you think about it here, and think about what you've learned, and then push play and come back to me. All right, so the first step, they've already got for you the factor, and now you just need to know your power of 10. So where is my decimal place on this whole number? Well, you don't see it, but it's right there, right to the right. So how many places do they move that decimal to the left? Well, here's 3, 6 jumps, 7, 8. They moved it 8 places to the left, so it's going to be a positive power of 10, so you'd have 10 to the 8th power. Okay, and this should make sense because, again, if I wanted to go from scientific notation back to my standard form, this number 3.5209 would become bigger because I'm multiplying by this positive power of 10 over here, and I would move my decimal place 8 places back to the right, and it would become, again, 352,090,000. Okay, look at number 2. Hopefully you've done this, or pause me. Now number 2, again, they have the first factor for you, and they went ahead and moved that decimal place to the 6 here, between the 6 and the 4. Why between the 6 and the 4? Okay, well, there's my factor, my number between 1 and 10. 6.488 is between 1 and 10. Now we know we're multiplying by a power of 10. The only question is, what's the power, and is it positive or negative? Well, we're moving the decimal to the right, so we know it's going to be negative. And we moved it 1, 2, 3 places, so it's going to be a negative 3. And it's going to be a negative 3 because if I was going to go back from scientific notation back to standard form, this number here is going to become smaller because that's what it was. It was smaller. So my decimal would move to back to the left because it's a negative 3 here. Okay, look at number 3 and 4 and see if you can write each of these numbers in scientific notation. Pause me and then hit play when you're done. Okay, so we're looking at 657 here, number 3 first. It's a whole number, So I know my decimal would be right there. And I need to find a factor that's between 1 and 10. So normally what happens is you're just going to have one number to the left of the decimal. And if that's the case, I'm going to move it 2 places right there. So my number is going to be 6.57 or 6 and 57 hundredths. And then I'm going to multiply by a power of 10. Well, I moved the decimal to the left, so it's going to be positive. I moved it 2 places, so it's going to be 2. So 657 is equal to, in scientific notation, 6.57 times 10 to the second power. All right, let's look at number 4. Okay, we're going to write this in scientific notation. So it's a small number, it's less than 1. We need to find the first factor, and I'm looking at these numbers, the first numbers I have, and I can see that I'm probably going to put that decimal. I will put that decimal right there, because that would make a number of 4.98, or 4 and 98 hundredths, and that is between 1 and 10. So now I have 4.98 times a power of 10. Well, how many places did I move my decimal? 1, 2, 3. 3 places. Make sure I put it in the right place there. 3 places to the right, which means it's going to be a negative decimal. And I moved it 3 places, so the exponent is 3. So if I was going to just look at this and say I had to change it to standard form, I know that my decimal would then move back to the left 3 places to become, again, this number. Okay, here are your problems. I want you to write each of these 4 problems in scientific notation. Okay, this would equal what in scientific notation? And then come to class tomorrow with a question. Good luck. See you tomorrow.